Okay, welcome everyone. This talk will be RabbitMQ hands-on. As you can see, it will be only my hands-on, but that's part of the plan. My name is Alvaro. I work for VMware. I'm actually a developer advocate for Cloud Foundry and RabbitMQ as well. So this morning, some guy asked me, like, so you work for 3 companies at the same time? No, it's actually VMware owns Cloud Foundry and RabbitMQ. I'm also, if you know, like from like the last century, I created that. Aral told me this is like 6 months ago. It's too old. I'm still like riding the wave of fame. Anyway, and I'm the author of the book RabbitMQ in Action, which I plan to give away today. If you ever saw one of my talks, you know how to get this book. If you didn't, then I will find a way to give it away. But in some conference, in the airline conference, mostly they know the secret. Anyway, so my first question I need to ask is, why do you need messaging? And actually, it should be, why do we need messaging? Because I think this is a bit pretentious to phrase that this way, but anyway. And to explain that, I want to go through how we build like classic web apps, and from there try to understand why we need messaging. So let's say I always give this example. I think it's pretty straightforward to follow and understand. We need to implement a photo gallery or an image gallery. And then we get some mock-up which says we need to upload a picture and then display the gallery. Pretty easy, and we say, okay, I can implement that. It will take me 1 week, whatnot. It's pretty simple until we start getting new requirements, as usual. I mean, whoever sat down and implemented something right away as it was defined? I don't have that experience. So we have a product owner. Let's say we are working in a Scrum kind of setup. And this guy comes to us and say, can we also notify the user friends when she uploads a new image? And I forgot to mention we need this for tomorrow. So we start like, okay, this guy comes to us and say, yeah, you cannot do it or what? Then we have the social media group, and it comes to us and say we need badges for users every time they upload a new picture. And also we need to post uploads to Twitter. There was a time when apps were really spamming Twitter about everything you were doing. And yeah. Then we have the sysadmin. And where I was working, we actually had Swiss admins, but it's a slight distinction. And this guy comes to us and say, damn, you are delivering full-size images. The bandwidth has tripled. I mean, but I was just asked to implement a photo gallery. Nobody said I had to resize images. And of course, this has to be fixed. I mean, if you are throwing money out of the window, you have to fix it. And I mean, this sounds a bit funny, but it actually happened in one of my previous companies. We had like a video delivery website. So they were not happy with us. So yeah. Then there is a developer in the other team. Sometimes we do continuous integration, as the previous guy mentioned. And he said that we need to call our PHP stuff from Python and even maybe Java. So why? Why do you want to do this kind of stuff? And then there is the user, which Aral, I mentioned him again, very well explained yesterday. We usually forget that there is a user behind the screen on the other side of the network. And as a user, if I'm using your website, I don't really give a dime if your application takes time resizing an image, if you need to tweet about it, if you need to tell your users, if your admin needs to get an email that there is a new image and needs to be moderated, or I don't know what. I just want to go to the form, click upload, and see the image there. That's all I care as a user. And we, as developers, tend to forget that, and we are always like, new requirement, we implemented, we shipped it. New requirement, implemented, and shipping it. And we really don't see that we are actually destroying the product we are working on. So one of the goals of Scrum is that you can come back with feedback to the product owners and tell them, hey, look, do you really want to do that? Do you really want to run this query over a, I don't know, 20 gigabyte database or 200 gigabyte database? We had this kind of requirements at a previous website I worked. And yeah, it was like the website was going to completely crawl if you do that. But If you just go and implement that, then the user won't like you. And then there is us at the end of all this storm, which just like flip tables, let's search for something else to do. So let's see the code evolution. I'm going to use pseudocode here because I think this is actually kind of Erlang code, for those that know. It's not that bad. There are comments, there are functions, there are arguments, and there is a function body. That's pretty much it. And there is no return. It's just the last value that gets called is what the function returns. So our first implementation was like, OK, we have a new image. We get the request data, whatever that is. We have an image handler, does the upload, finito. Then the guys say, OK, but we have to resize the image. So we went there, resize image, finito. We need to notify friends. So we keep adding code there. We need to add points to the user. Of course, each of these changes require that we redeploy the code again. We need that to tweet the new image and so on. So can this code scale to new requirements? Because usually when we talk about scaling, we say, OK, I will be in the cloud. I will launch I don't know how many servers, and then boom, scale. Yeah, but you need to think about also new requirements, or if you need to scale down, have less servers. What happens when you don't have that many users online? Do you really want to spend money on those many Amazon web services or what not? So what if we need to speed up image conversion? You have everything there in your controller. How do you do that? Or even, yeah, maybe we are refactoring and we don't have really the actual image resizing code in the controller. I mean, if we do that, we deserve to be working in some other industry, but not really as developers. Anyway, how do you speed up image conversion if you have your big web app and your controller there is calling a PHP function that does the resize? You need to just have more PHP servers. And if you have like a whole project there, as it usually is with all the controllers and whatnot, you will be firing more PHP web servers, but you just need to have a speed up in image conversion, not really in some other controller that we don't really care. What happens if the notification they need to be sent by email instead of Twitter or whatever? What if we need to stop tweeting about new images? What if Google decides that it needs a new social network and then you need to use that social network instead of Twitter? What if you need to resize in different formats? What happens if you need to swap the language or the technology without downtime? Yeah, for example, doing image resize, OK, in the case of that in PHP, it's not that bad because you're using image magic probably, which is in C, so it will be fast enough. But if you're doing like XML parsing or JSON or I don't know what, you may need to switch to a language that will give you better performance in that regard. So can we do better from all this thing? Of course, my solution, the one I come here to sell you and will be signing contracts outside, is about using messaging. So there is a very simple design. We all know, I mean, if you use Twitter, you know that already. It's the publish subscribe pattern. You just send an event. This is taken from the wow, it's, I always forget the name of the book, the Enterprise Integration Patterns book. This is kind of open source images they have there, Creative Commons. And in this case, they implement the publish subscribe, and they say, OK, I have a publisher, sends a new event. In this case, address change. It could be new image, whatnot. And we have many subscribers. This will do one thing, this another, this another. If I need a new subscriber, I just put one more there. And it's the same as, for example, whenever I tweet, this tweet will go to all my followers. They can retweet it, delete it, ignore it, and whatever. So what will be our first implementation? We have the controller. We will get the data from the request. We will do the image upload. This is moving the file to some storage, some hard drive somewhere, I don't know. We get the data back, like image handler do upload, return the image data, plus OK. And then we create like a record data saying, OK, our message has some user data and the image we put on the database, and we publish a message or a new event saying new image and the message. Then we create a script, which is the friends notifier. It will say, on new image, do that. On new image, the points manager will add points to the user, and the resizer will resize. So what's the second implementation? There is no actual second implementation. And actually, if you go back to this code, sorry, what do you have? You have that you deploy that, and that's it. You don't need to redeploy this code ever. When you need to have the friends notifier, you deploy that part of the code, then this one, then that one. If we don't need this one anymore, for example, just take it out, everything else keeps working, and you don't need to touch that other one. You need to swap the language, you need to scale, you need to do whatnot. It all will work from the first deployment, and I mean, this is not rocket science, and it's just very basic event-based programming. So then we have RabbitMQ, which is the technology I choose for messaging. So RabbitMQ, for those that don't know, is a multi-protocol messaging server. It's open source, and it's part of Spring Source since like 2 years. It's just an anecdote. It doesn't really change anything. There's only more money for people to develop the product, basically. And RabbitMQ is polyglot, and it's written in Erlang OTP. It's multi-protocol. This means there are many protocols you can use to actually talk to Rabbit. In this case, you have ANQP, MQTT, and Stomp. And there is a blog post that was written like a week ago or so, where they explain which one you should choose and why. But basically, RabbitMQ started as an ANQP broker. Then, via plugins, they had MQTT and Stomp, and also there was some integration with XMPP and whatnot. Basically, some protocols are more complex than others. They give you more freedom or less freedom than others, and they have bigger or smaller requirements at the CPU level. For example, as far as I know, MQTT is used by Facebook on their iPhone iOS chat, because it's very slow, very small, sorry, in the requirement it needs from the CPU. So it will be very battery friendly. And also, it works on unreliable networks and so on. So really depending what you do, it's what you use. Stomp is a text-based protocol, similar to Redis or Memcache. So in the CERN, for example, uses for the Large Hadron Collider Stomp, and in some part of their infrastructure. They also use JMS, they use ActiveMQ, they use Rabbit, they use ZeroMQ. There is a lot of queuing things there. But yeah, there is a solution for each problem, basically. And when we say that Rabbit is polyglot, yeah, you can actually use it from many languages as long as there is a library for that what you want to use. You can use Rabbit. In our case, I maintain one of the PHP libraries. As usual in PHP, there are like 5 libraries because we like to implement things many times. Then there is the Node.js one, Erlang, Java, Ruby, .NET, Haskell, and whatnot. The only difference with the Erlang, .NET, and Java is they are maintained by the RabbitMQ developers. So whenever there is a new feature in Rabbit, there's probably already in those libraries. That's the only advantage from using those languages. I mean, of course, those languages has other advantage, but I'm saying in this ANQP sense. So you probably want to know more about how RabbitMQ actually works. So let me get out of here and come to the browser, and then localhost. I hope you can see that. There's my user interface failing to me. So I started creating this project because I wanted to demo how RabbitMQ actually works. This is a very much work in progress. Its interface is, as you can see, very, very basic. I don't even change the colors of Bootstrap. It's just the guy in the back. Can I change the resolution to have it wide screen? Hello? Can I change the resolution to have the wide screen? Because it's not filling my whole screen here. Let me, which one should be? Sorry for this. Please. Cool. I love this part of the new Safari. There. Okay. So with the RabbitMQ simulator, this simulates what how RabbitMQ works. It's not really the broker running, but it's enough to explain how Rabbit works. So whenever you use messaging, you want to have a producer creating data and sending this data to a consumer. The consumer will be your worker or whatnot processing those events. So you want to get the data from this point to here. To do that, you need an address. This address in RabbitMQ is called the exchange, which will get your messages. So whenever you want to send a message, you will tell your publisher, send them to an exchange. That's it. Then you click here. You say hello or PHP UK, send, and that's it. But the message didn't go actually anywhere. Why? Because we need queues. This abstraction, which seems a bit dumb at the beginning, like why they do that. I want to have the message arriving to the yellow thing. You have the exchange first, then the queues. I will show in a bit why you actually need this. Then you have the queue there. So if I go here again and then click send, you can see that the messages are actually being queued there in the queue. And now, yes, we can tell the consumer or worker subscribe to this queue, and it will start getting the messages. So that's the most basic setup you can have in Rabbit. So what's the advantage of having the exchange? The exchange is similar to when you in your mail inbox you have rules. So you get all the mails there, but then you send them to different places to process or read them at different time, differently and whatnot. So an exchange can actually have more than one queue. And then again, when you send the data, the messages will be fan-outed to as many queues as you have there. But it's not just that. When you have an exchange, you have different exchange types. What does it mean? It means there are different routing algorithms that the exchange will take to take your message to the queue where it should go. So actually, let's say you are sending a message from this producer, and you want to have a routing key like logs. I don't know. Then you click send. Nothing happens. Why? Because this is actually a direct exchange. This means it will actually check the routing key that you publish the message and see if it matches with the binding key of the queue. It says binding key here. This was my usability solution to not display an empty routing key, because then you cannot actually see anything. But in fact, it's an empty routing key. So if I write logs, change, come back, send, then only that queue gets the message. The other queue doesn't get anything. So with direct exchange, if the routing key matches, the message goes there, basically. But then you have one exchange, which is the fan-out, where you completely ignore the routing key. So if you really want to send the message to every queue bound to a particular exchange, that's how you do it. Of course, you can have more than one exchange, more than one queue. There cannot be even bound to anything, so that's not it's not a problem, let's say. And then the last exchange type is the topic exchange, which is the most advanced one. So by default, the topic exchange works kind of like the direct exchange, checking routing keys. But you can use patterns. So let's say you deploy your app and you want to see if somebody is actually using your application. So you have a cluster of servers. Let's say server 1, that's the host name. And then you have like application 1, module 1, and error. So an error happened there, right? I hope you can see this here. That will be the routing key I will be sending the message. This is at the application level. So if you're in an app and you produce a message, you know in which module you are, you know in which server you are and whatnot, right? So if I send the message, it goes nowhere because the routing keys, they are not matching. So I can actually go and write this here, change, and send. And it goes, yeah, okay, what's the point, basically? I can come here and say, yeah, I want to have, I don't care, for example, if it's an error, info, warning, or whatnot. So I can use a star. I hope you can see that. I can use a star there and match one word. Change. So if I send the message now, it goes to both queues. It can even go further and as saying, I want to have one listener for logs from every server in the system. So instead of saying server 1, I can say star, and here star, change. Then on the producer side, I can say server 2, for example, and instead of error, I will send a warning. And it only goes to that one because it's listening to no matter what the server and no matter what the log level is. And the final bit is the hash. And the other day I heard a very weird name for that in English, which actually a German speaker told me I cannot reproduce that, but I used to call it sharp, like in music. I used to play music, so for me that was a sharp. Then I learned that it's not actually a sharp, it's a hash, whatever. Anyway, change. So what the hash is doing, it matches 0 or more words. So if I send, I get everything. So this queue will actually get every single log out there. But I could restrict that to say only info. So this will mean I don't care about the server, I don't care about the app, I don't care about the module, but I do care that it's an info. So I will change, come back here, please, and then info, send, and it still goes there. So you have words separated by dots. That's how you build up those patterns. Then you have stars which match one word, and the hash which matches 0 or more words. That's basically how the topic exchange works. And in this case, if you want to build a distributed log system, you can really do advanced stuff. Like you know the website is being slow at the moment, you fire that, and you start seeing which one is producing which logs. Then you can kill your consumer, start a new one, and say, no, now I really want to have a queue for server 1, because you see that server 1 is the only one producing logs, and you can start concealing the problem, or not concealing, like running around the problem, sorry. So any questions up to here? Yes?
Yeah, the hash, is that a duplicate? So if you send one message, I saw 2 come off. Were you just sending 1? Is that a duplicate?
No, RabbitMQ will do like a smart way of storing messages. So Rabbit has an index of messages plus the place where they are stored. The index keeps track on which queues they belong, but the message is stored only once. Okay. Even if
it's on 2 queues, though?
It will be in 2 queues conceptually. So you can actually, I could come here and bring a consumer and do this, and I start getting messages there. And something I didn't mention is like, you see this queue has 6 messages, right? I can actually have 2 consumers, and then they will be round robin around the consumers automatically. Then there are more details like a consumer, if it fails, the message will be back in the queue and whatnot. And the secret to win the book is to ask the first question. So this for you. So don't ask random questions, please, in the next time. So anyway, you can tell me later. Yeah, let me know what's next. So that was a big overview of what RabbitMQ is. Just as a note, people ask me what did I use to build that. I'm using processing.js, which is created, or a port of processing, a Java project ported by the jQuery creator, Sean Resick, I think. And it's pretty cool because you work with objects, so you really have I mean, for this kind of interfaces, objects are pretty well designed. So you have exchanges, I can extend to different types and so on. So it's very actually easy to build these kind of things with processing. Besides that, it's not just a toy, as people tell me sometimes. I can actually import configuration here. So now I'm not running Rabbit, but if I would be running Rabbit, I could click import, and my whole messaging topology will be drawn there on the simulator. So I can actually click around and see why my message didn't get where I wanted to be sent. So that's a huge, a big tool for debugging a production system in messaging. Because messaging, as they say, is the architect's dream, but the developer nightmare. Because you have, oh yeah, this is very fun, things going around, but you cannot actually see anything because everything is going through the network, there, somewhere, magic. So yeah. And besides that, yeah, you can also export the architecture here. This same design, I can actually send a post to Rabbit and will create the queues and whatnot. And then this 2-player, I'm not really finding a good name for this, but basically this piece of JSON you can see here is the representation of this whole bunch, which if I want to write a tutorial, a lorem ipsum tutorial, I can actually export and have it there, or like this. I actually draw it with the simulator and had that. So you could hand that as a document. We could write better RabbitMQ tutorials using that, and so on. So that's one of the goals of this toy. Anyway, back to the slides. So yeah, this is the hands-on part. You probably want to see code, or it didn't happen. So I'm using this library, PHP NQP lib. It's not created originally by me, but we took it over at a previous company when I was in China, and we fixed many bugs it had for working with PHP 5.3, basically with a strict mode. And because we weren't really good open source citizens back then, we kind of just fork it out and never actually send the patches back, and then it just diverged way too much, and yeah, we just release it on GitHub. Of course, giving credit to the original authors. And from there, it has come a long way. Now it has PHP namespaces. You can install it over Composer and whatnot. So code, or it didn't happen, right? So here I'm in the command line. Is it too small for the people in the back? Probably. Sorry. So here I'm inside my computer, you can guess, and I just have an untarred RabbitMQ server. So basically, Rabbit will be distributed. There are many ways. There are Ubuntu distros and many ways, but I prefer the tarball. So you just untar that, and then you have a folder like this one. And there, oops, you will have like, ooh, this is not the best color, sorry, basic. I think that will be better. pwd copy. So, sorry, there. So you have the Ebeam folder, that's a binary from Erlang, etc, where you will put the configuration, include are the RabbitMQ includes, you don't care about that. You have plugins that come with the broker. So stay there, computer. I'm very scared about that with this thing Newton invented, the gravity. But I cannot see here. Yeah, here, RabbitMQ Stomp, that's a Stomp protocol plugin. So the broker can be really extended, adding plugins for almost whatever you can think of. Yeah, there are like Shovel plugin, which lets you replicate data across many brokers in a wide area network. There are JSON RPC, federation, consistent hash exchange. I didn't mention that exchange, but it's a plugin you can add. Like you can have consistent hashing distribution of messages across your queues and many things. So we have plugins, and we have the commands that you will use to control Rabbit. Mostly you will care about RabbitMQ CTL and RabbitMQ Server. And inside var, here is where your actual database will go and your logs will go here. The database means the messages, where Rabbit will store them. Anyway, so how do you start the broker? I think, let me see if actually running. No, so to start the broker, you will type RabbitMQ Server and detached. If I don't give this flag, it will stay in my console, basically. So I want to send it to the background.
Would you want
That's
to
it.
the window just a little to the right?
Yeah, sorry. Right there. Yeah, sorry for that. Yeah, so I started the broker. This was the command, if you couldn't see it before. RabbitMQ Server detach. And then, for example, I can check with the RabbitMQ CTL status. And it will tell me memory used by the server or whatnot. You don't care about that now. Then, how do I actually use that? Let me see something as RabbitMQ plugins list. So these are the plugins I have, and I have the management plugin enabled. So I can actually come here and do 15672. So I have even a web UI to manage the broker. Guest is the default user and password. I can log in, and I can see what's happening on the broker, like file descriptor, sockets, Erlang processes, memory, disk space use, and so on. You can list connections, channels, changes, queues, and so on. So that's for the basic overview on how you start it, what comes with it. So let's go to PHP. So, yes. So I'm using this library, and in the library, you have a bunch of demos on this demo folder. So if you want to see or get started, there's a lot there. So let me get back to TextMate now. Downloading TextMate, no thanks. There. Please. So how does it work? You will have a configuration file somewhere, like this one, for example, where you will say, I want to connect to that host on the 5672, which is the default port, a user and a password, and then a virtual host. The virtual host works similar to Apache. You can have many virtual hosts, and then the queues and exchanges will be separated on those virtual hosts. And you can see the back configuration or on or off. Anyway, what you want to do then is to have use that to create a connection, and from the connection you will get a channel. So, sorry, in the context of PHP, channels don't really make sense because you have only one thread. But in Java, Haskell, Erlang, Clojure, whatnot, you could use channels to have threads, for example. But you still do need the channel because that's how the protocol works. So you have one TCP connection and many channels they are getting and sending and receiving messages. That's it. So this is the part where you start hating an NQP because you can see false, true, true, false, false, true, true. I don't ever know what they mean. That's why I have these talks there. So you will do a queue declare on the channel. What are you trying to do here? You're trying to create a queue on the broker. But why is it called declare? Because it's not actually creating the queue. Declare means create if not present. The advantage of that is that you don't need to do, let's say you build your own queue system using MySQL or some database. You want to see if the table is there, create it. If not, do something else. Declare will save you that step. So you just give the queue name and some parameters, like passive means that don't declare it. I just wanted to see if the queue was there. Okay. Then durable will be if the queue will survive a server restart. Exclusive will mean if the queue only belongs to this connection. And auto-delete means if this connection goes away, delete the queue. In the case of the login example, you can just fire a consumer with an exclusive auto-delete queue. When you kill the consumer, the queue is gone from the broker. So you don't need to do cleanup, for example. So again, NQP is very complex, but it has a lot of options, freedom, and whatnot. In the other protocols, you maybe need to invent the protocol yourself at the end, or if you use a non-protocol broker. Okay, you have the queue, but you actually needed an address where you want to send the message. So that's the exchange declare. Same concept, you give the exchange name and the type. And then again, if you want to be passive, durable, and whatnot. Then you will do Qbinds. If you don't provide a routing key, this will be sent by default. So you say, please bind this queue to this exchange. That's it. Then somewhere you will write a function that will process the message. We'll get a message as an argument, and then you will use that. You will do whatever you have to do with the message body and even with the headers of the message. Where do you use that? You have basic consume. You will tell Rabbit, OK, I want to consume the message. I want to assign a consumer tag. Why do you need the consumer tag? Because then when you want to stop consuming, you can tell Rabbit, hey, don't send me any more messages. This was my name, or this was how you used to know me, basically. And there are many parameters, yes, but you care about saying, whenever I get a new message from that queue, send it to that function. This function is just a PHP callable, so it can be a static function in a class, an object plus the class name, and so on, the function name or method name. Anyway. And then you just, while the channel has callbacks, you wait on the channel. So they will block and wait for incoming messages. As you might guess, NQP is mostly useful in if you have like long-running processes like cron shops or something like that. Anyway, so let's start. Let's start this consumer, and I will do PHP demo NQP consumer. And there, the consumer is running and ready. If we go to the web UI, we now have a connection, we have a channel. There is an exchange I call router, and there will be the queue for that particular consumer. I now want to send messages actually to this consumer. So let me resize this a bit. So I have a producer. The code of the producer is very similar. Let me find it, MQP publisher. So at the top is the same. You get the connection, get the channel, you declare the queue, you declare the exchange, you do the binding. This is boilerplate, basically. Then from the arguments I pass on the command line, I get a message body. I create an NQP message. And this is what we care, channel publish. It will be for the people in the back. So I will send this message to this exchange. The exchange up here is router, the one I used before. So how do we do that? PHP demo MQ publisher PHP hello. And the message, oops, again, same thing, is there. If I do it again, it will go again. So that's pretty simple. Then, of course, I can send more than one message per connection. 0, E less than 100, E plus plus. Oops. So yes, looks like it's right, and I can do that. And there were the 100 messages. And of course, if I were to start a new consumer, then they will start seeing one will see the message, the other, and so on, doing round robin. So that's the basic publish subscribe thing you can do. If you use a different exchange type, then you will have the benefits of using fan out for PubSub, having the topic exchange if you wanted to do logging or more advanced use case. And as a consumer, you are not limited to just processing the message. I'm not in the message you have access to the channel. The message will have a delivery info property where you can have the channel. And for example, you can acknowledge the message. So you are telling Rabbit, delete it from the queue. I actually could process it. If this crashes before this step, the message goes back to the queue. Then if I send a message with the body quit, then okay, I want to cancel consuming. So the consumer tag here and telling Rabbit, hey, I'm gone. Please don't send me anything else. From here, I could actually, because I have access to the channel, I can do channel publish and send it to the next step. So if you build a workflow system when you have one step, another, you can have this publish on the process messages and so on. You can do RPC servers, whatever. So I'm running out of time. Any questions up to here? There are no more books, yes?
Regarding the queue and the consumers, will the same message be sent to all the... Thank you. I don't know if you heard me.
Yeah, so the question is if the same message is sent
to multiple consumers.
So the answer is no. It's a queue, so every time you get a message out of the queue, it's not there anymore. So the next consumer will get the next message, unless, of course, the consumer crashes, and then it will go back to the queue, and then some other consumer will get it. But
so it's behaving like a stack then?
Yeah.
Okay, thank you.
Yeah, but the stack is the last in, first out, and this one will be the other way around. So as a kind of a conclusion, what happened with messaging? We can scale across consumers. We can scale in the process of developing our application, because we can just say, okay, now I want to publish an image and resize it, but later I want to do something else with that image. We can hook up this with Rabbit, and it's easy to scale. Even if, let's say that consumer I showed just published a message saying, I'm done. You have it there. Maybe there is no queue getting those messages, nothing happened. But in the future, if you want to do something else after the image was resized, you already have this event there that is telling you that is happening. And Rabbit can do easily, like in PHP, 4,000 or more messages per second. In PHP, in Java, it goes up to 12,000 or even more, and depending on which server. I'm just talking about a Mac. So it's pretty fast. You have the coupling. Again, you can just plug and play stuff around. And you can have polyglot apps, which are very interesting today. And in current web shops, you may have a guy that wants to do Node.js, and another guy doing Clojure, and the other doing PHP and whatnot. You cannot have 1,000 languages in your project, but with messaging, it will be easier if for some particular task you need that particular language. So questions? The last one here, because I think we don't have more time. Yes?
How does it compare with something like Apache messaging?
Like
ActiveMQ?
Okay, so ActiveMQ mostly works on, I don't want to talk about what I don't know, but as far as I know, it works mostly on JMS and Stomp. It may support a different protocol, I don't know. But as far as I understand, it's easier to be used from the Java platform. I'm not saying it cannot be used from PHP or any of the others, but that is what I will say is kind of a disadvantage. But I'm not saying it's not stable. I'm not saying it won't solve your problem. So I don't like to enter in that area. There was a guy in the back first. Yes?
Sorry, I wasn't here at the beginning, but what kind of security stuff does Rabbit support?
So you have authentication per user.
Yep.
Then the messages you can, if you set up the user ID, that send, when you publish a message, you actually instantiate an AMQP message, which has a content like a payload plus headers. In the headers, you can set up the user ID. Yep. And there, for example, Rabbit will check if the actual user consuming the messages is could get that message. Then there is a policy where users can read or write or configure the broker depending on what resource they are trying to access. So there are many levels. Then you have SSL, you have LDAP authentication, the basic AMQP authentication. A guy now is writing an Active Directory plugin for hooking a new authentication mechanism in Rabbit. So there are many options.
Thank you.
Here.
The microphone. As a, sorry, this is on. It should be right now.
Hello. All right, great. As an independent developer who wants to limit the amount of ops that he does as much as possible, is there a hosted solution or hosted solutions that you would recommend?
There are many, actually. In our case, if I had to recommend one, is Cloud Foundry, of course. But yeah, there are many. There is like Cloud AMQP. They're specialized in Rabbit. I know Heroku probably has a RabbitMQ add-on. Cloud Foundry comes with RabbitMQ support by default. There are many, but yeah, that's what I know. So thank you very much then.